Welcome back. Today is day 9. I'm so excited to be here. I hope you are all very excited to have shown up. Showing up is so important, whether you're live with us or you're returning to this video at a later date. Thank you for showing up. This week is all about interacting with each other using math as a way to communicate. So while we are getting our viewers, I just want to take some time to reintroduce the whole point of this journey. Author Elisa Vitti, CEO of In the Flow, really inspired me when I read her audio, or I listened to her audiobook, and she talks about how some humans have just a 24-hour cycle of energy levels and body functions, and some people have also a 28-day cycle along with the 24-hour cycle, and she relates these to the sun and the moon. So I hope that this journey gives you a daily practice, but also sort of a monthly practice in terms of how you can cycle back through your learning. Now, I love math. I consider myself a math fanatic, and this is my passion. So please realize you can take all of these ideas of cycling through a learning experience daily and over 4 weeks to anything that you're interested in. Okay? So without further ado, welcome. It's the new moon. The week of the new moon, we are really focusing on collaboration. You should have already shared and pitched, so you should have shared some ideas with somebody that was open and free of judgment for you, and then pitched those ideas of how you're going to express yourself creatively using the golden ratio. So far this week, I have shared with you all many things, but then also I've pitched my idea for my canvas painting. Last night, I uploaded the supplemental video on how I actually took my design from my pine cone and used scale drawing and arithmetic and ratios and proportions and some serious mathematical reasoning, made some mistakes on how I came up with my sketch for my canvas. So check that out on Muddy Math's YouTube channel. I'll link the description below once this gets sent back up to YouTube. So you are collaborating. Now I need to collaborate with others so that this can get better. So in order for me to collaborate, I really need you all to go to day 9 on muddymath.com and leave me feedback. So especially if you've watched this video on how I made this sketch, okay, please go to muddymath.com on day 9 and leave a comment so we can really collaborate, okay? I really encourage you to practice your digital presence, your digital ways of collaborating. It's a really, unique opportunity that we have to collaborate digitally. So with parent permission, please go to day 9 collaborate and leave me a comment. I need your honest feedback. Sure, you can be kind. Kindness gets us far in this world, but I also won't learn unless you're honest with me. So please give me honest feedback on my design and how I'm using it to understand the golden ratio better. So to activate today, you are going to need to look at a coordinate plane. So let's get activated. Let's get ready for our lesson. Today we want to learn about how an angle, a point, the word center, a tangent, circumference, radius, how are all of these things going to help us understand the golden ratio better and further be more confident in our creative expression. So what you want to do is match the description to the element on the coordinate plane below. So if you take a look, you see there's a coordinate plane. This is the points that I made on Canva of my pine cone, and I picked one of the spirals, and this is the same spiral we worked with yesterday. In the supplemental video, I show how to calculate average rate of change. The supplemental video 2 from days 7 through 10 takes us into great detail about how to find average rate of change using the golden spiral. Okay, so you can check that out if you like. But our activator is match the description to the elements on the coordinate plane below. So which element is best described by one set of lines represent the tangent to a spiral. Ooh, that's heavy. That's some heavy math words. That's communicating mathematically. One set of lines represent the tangent to the spiral. A tangent line only intersects a single point on the curve. So remember, the blue dots represent points on the curve. Okay, which of those elements is only going through a single point on the curve, and it represents the tangent to the spiral. Okay, maybe you're right, maybe you're not. Let's keep going. So the second description is one set of lines represent the center of the spiral to the center of the scale on a pine cone. Center of the spiral to the center of the scale on a pine cone. Okay, which one matches with which element? So I'm going to kind of flip-flop my screens here. I'm learning. I recognize that when I'm teeny tiny on your screen that you can't really see me. So then let me pull the PDF. Oh, that's not the right one. Here we go. All right. So one second. There we go. Man, patience. Hey, give me some pointers. Leave a comment on muddymath.com if you have some pointers for me for live streaming, if you're better at it than I am. Okay, so if we look at, so grab your pencil or go to desmos.com, or you can go to geogebra.com. Those are great websites for graphing and plotting. But if you are sticking traditional with a piece of paper and a napkin, or a chalkboard, or whatever you want to work with, okay? Here's your coordinate plane. The center of the coordinate plane could be considered the origin. Okay, that's where the points 0, 0, an x value and a y value of 0, 0 line up. Those of you that understand proportional relationships, remember a proportional relationship must relate 0 to 0 somehow and have a straight line. So, but in this case, we're not dealing with a linear relationship. We have a spiral, a golden spiral at that. Ooh. Okay, so let's take a look at that first point on my golden spiral. It's really close to the y-axis. Okay, it has a line connecting the point to the origin, and then another line kind of branching off. Now it's hard for me to guess where the next point's going to go without the next point on the spiral. So I'm going to go ahead and plot maybe 2 or 3 points from the spiral on my whiteboard. And I encourage you to try this, okay? Practice, practice, practice. Draw a golden spiral 10,000 times and see how you improve. And the really fun thing about practicing something repetitively that you're interested in is along the way you begin to realize that you're uncovering more and more, and that it takes you to push yourself to the limits of your understanding to get something out of an experience. So make sure that you are staying positive, you're finding the edge of your understanding, and then breaking through it, oftentimes breaking through it by looking at something in a different perspective. And those perspectives often come when you collaborate. So collaborate with others so that you can hear other perspectives and maybe understand something in a way you never imagined. Okay, that beginner's mindset that Adrian Mishler always talks about in Yoga with Adrian. Okay, so we have all of these. So this is an element that was described. Is this the element of a set of lines representing the tangent to a spiral, or a set of lines connecting the center of the spiral to the center of the pine cone scale? So if you look, all the scales on the pine cone have a little mark. It's like a little dot. And that's what I'm talking about for the center of the pine cone. And so the blue lines are representing the distance from the center of the spiral to the center of the scale on the pine cone. Okay. Now, I added center of the scale on the pine cone because I realized we've been using the word scale for scale drawing. And that's another fascinating thing, that in math we use words differently than you would use them in a common conversation. So you might think of scale in terms of like a scale of an animal or a scale of a pine cone or a scale, I would think maybe on a snake, right? But we talk about scale in math as, you know, a scale drawing, putting something to scale on a map, on a drawing. And so I added on pine cone to help me collaborate better and use precise language to really help you all understand what I'm saying. Okay, now these are practices you are going to try when you are collaborating with others today about your creative expression regarding the golden ratio. So we have these lines, and so this one's not going to work because if I look at where my golden spiral would go, okay, the tangent line cannot go through the spiral more than once. It can only touch the spiral once. Okay, so spoiler alert, these are the tangent lines. Okay, and look at that. We've already used the word center. We've already used the word point. We've already used the word tangent. Okay, so we're on a roll here. Now, why am I talking about calculus concepts when this is supposed to be a middle school production? Remember, middle school can be a wonderful adventure for people of age 60, below 6. It doesn't matter. You make this what you need. So if you're just practicing drawing spirals and then maybe putting them on this big plus sign known as the coordinate plane, then that's for you. If you are a calculus guru and you are ready to deal with differential equations, then go for it. If you are with me and you're just kind of trying to understand this relationship called the golden ratio a little bit better, so that I can make a really cool painting, then stick with me. So you need to find the edge that's good for you. You don't want to fall over the edge. You want to push up against the edge and then progress. And then you don't want to stay too far back from the edge that you never get a chance to experience the coolness of learning, right? Okay, so let's look at the word angle. Why is this important? So the reason I had you all activate with this, because this is a way to understand spirals better. That the idea is something is in a spiral if the angle of the line connecting the edge of the spiral to the center of the spiral, this angle here, is supposed to be present through any point on the spiral. I should be able to find this angle. It should be congruent, these measurements from the center of the spiral to the spiral, and then the angle formed with that line and the line that's tangent to the curve. Tangent to the curve. So you can see that my sketch is not perfect. Okay, I'm not getting the exact same angle. Okay, these are much more obtuse, and then around here the angles become more like right angles, and then up here they start to get obtuse again. So the idea with a spiral is that that angle is the same measurement all the way around the spiral. That's pretty cool. I learned that in my explorations this week. So when we look at an angle measurement, we know that this is a right angle that's 90 degrees, okay? Wider than that is called if it's greater than 90 degrees, is obtuse. And mine were obtuse in the beginning, and then they kind of went to right angles, and then they are starting to return to obtuse. Okay? We can look at this exact same obtuse angle, but call it a reflex angle. Instead of mapping the degree distance from here to here, we can go around the outside, and that's called a reflex angle. That's greater than 180 degrees. 180 degrees is two 90 degrees put together. It's just a straight line. Okay, so just a quick review on angles. Now, if I have my spiral drawn correctly, then all of these angles will be equal. What I read, though, is that it's not an exact science, really, on finding by eye the center of the spiral. So my problem could be that my spiral center is really maybe over here, and then that might make it a more congruent relationship between the line from the center of the spiral to the tangent. Okay, so why I have circumference and radius up here is because a much more straightforward relationship in nature is that relationship of the circle to the diameter, okay, and the radius. So I'm going to draw a circle that has this as its radius. From here to here is the radius, and this is going to be the center of my circle. And in doing so, I need to maintain that the entire distance all the way around the circle from the center to a point on the circle is the same length. Okay, and so this is another good practice drawing circles. I know SpongeBob has a really cool video. Well, SpongeBob doesn't have videos, but there's a cool SpongeBob episode where he learns how to draw a circle. Or shows how he draws a circle. So that's wobbly, right? But that's okay. And so how do we relate a circle and a spiral? A circle reconnects, whereas a spiral will continue in infinite directions, both super, super teeny, tiny, small, and then really, 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 really huge. A really cool app that I saw regarding that was on geogebra.com, and they have this infinite zoom of the golden spiral. So I'll get that up, and I think I linked that in the Day 9 blog post. So actually, let me just go there. Okay, but what we're going to continue on is how can coordinates help me make a scale drawing? And what you can do is multiply the coordinates on your spiral both by the same value, and it will enlarge the spiral. So this is the last activity we're going to work with today. So to join me on this activity, what I need you to do is either go on to Desmos.com and plot some points, okay, or you can draw on paper some points that look like a spiral. So these are the same spirals I chose from yesterday's lesson, and we're going to enlarge them by multiplying them all by a number, a constant. So we're going to multiply all of these coordinates and show how we can make a scale drawing by multiplying coordinate points on the coordinate plane, okay? So while people are getting ready with either Desmos.com or a piece of paper and a pencil to plot these points, I'm going to just show you the link that I was talking about. So if you go to, if you just type in golden ratio GeoGebra, it will come up with the collection of phi apps and programs, and the infinite zoom is just what I was talking about, that the circle reconnects, but the golden rectangle or the golden spiral, it repeats forever and ever, infinitely small, infinitesimally, I always struggle saying that word, small and large. Okay, so it'll never reconnect with itself. All right, so enough of that before you all get dizzy. So let's just practice scale drawing really quick by plotting points on the coordinate plane. And so I guess we talked about radius. We didn't talk about circumference. The circumference is the distance all the way around the circle, and that compares to the spiral because the spiral has an infinite length, whereas the circle has a definite length, a defined length. So that's kind of that connection there. But let's go ahead and show scale drawing with a coordinate point. So if I have the point 0, 0, and I multiply 0 by any value, it's staying the same. So this will be the same point for the large and the small drawing. Okay, so if I have a spiral that starts, let's call this -1 and -3. Okay, if I multiply both of these by 2, then I'm going to double the size of my drawing. And I'll get -2 and -6. So then I go to -2 and then double that at -6. Boom, there's my new point. Okay, and then, so say my next one was at, I don't know, here, we'll say at the point 0, 0, -5.5. So we went 0 in the x direction, and we went down 5.5 in the y direction. Okay, so what is that going to be once I double it? What is that going to be once I double it? So I'm going to multiply 0 by 2 and -5.5 by 2. 0 stays the same. It's not going to go any further in the x direction. It'll stay on the y-axis. And then -5.5 times 2. Well, I know -5 times 2 is -10. A half times 2 is 1, so that's -11. So double this and I get to 12, so -11 is probably there. Okay, and then one last one so we can kind of see the spiral coming around. Let's say we are at, if that's 3, that's 3, so that looks like 4, -5. Again, to enlarge this, we're going to multiply everything by 2. We get 8, -10. So we're going to double the 4 to 8, come down here, and bring 10 over right about there. So here's the double spiral, or the spiral that's twice as big, and here's the original. Okay? Canella, be quiet. So on that note, my dogs are going to start barking. Thank you so much for showing up. Get collaborating on your creative expression for Phi. I hope you peel away any anxiety you have about math. Use this time to connect with yourself, connect with others, and connect with nature. It's proven, Canella and Snoop, that just by looking at fractals, you're going to have a more peaceful time. So, more power to you. Bye, guys.